Welcome back. In this video, I'll be going over some weird tech that I reference fairly often without much explanation on what it actually is. We aren't entirely sure what to call it, but generally we call it the dictionary system, but I guess it would be more accurately described as a lookup table. Now as a forward, me, TS, or Suzo did not come up with this. This was actually thought up by Misode. Initially, this was created for the text-to-speech system. We needed some way to get phonetics for any word in the English language in an efficient way. The idea was to create a list of all words, split them into individual characters, and then use those split characters as indexes in a list. At the end of the index would be an array of phonetics to create that word in the text-to-speech system. This allowed us to have accurate pronunciation in the text-to-speech system for known words, only falling back onto the word parsing system I created for words we couldn't find in our list, since, admittedly, my phonetic system wasn't the best at replicating how English sounds. So let's get started with how to create a basic lookup table, then I'll provide a few more examples of uses, as well as some updates on some projects of mine at the end. Now to start with, let's go over the data structure. For this example, we're making a tree for a string that is up to 3 characters long with characters A and B. The scale of this is small, so it's actually readable, because these lookups become very unreadable very quick, especially because they're basically in JSON, which in my opinion is the worst way to visualize a data tree. In this, we have all possible combinations of those 2 characters with lengths 1 to 3, giving us 14 different possible strings. For formatting, you have each character of the string as an index, and then something you would never use as an index to mark the value you want to access. So in this case, you can use something like end. This would effectively allow you to flatten the string BBA by using the index b.b.a.end. The end index is only required if you have a non-fixed length tree. I will go over fixed length trees here shortly. So now that I covered the data structure, let's go over how to grab the data. If you create an array of characters, numbers, or whatever you may be using as indexes, you can use those to access the indexes without having to hardcode accesses. My example function here is for the data tree we created earlier. I have here a command that copies the lookup from a hold location onto the index we'll be using to actually read the tree. The reason I am copying the data from one place to another is because we override the data onto itself recursively in a way that cannot be reversed and reused again. After I write that data, I run the lookup loop function. This actually reads the tree based on our input array. The first thing we're doing in this looping function is write the character into an index. In storage, we can easily check with execute if data. Here I use char, and then after the letter is copied to that index, I remove it from the array. The next thing I do is copy an index based on the char that I copied. If you look where I am copying from to where I am copying to, you can see the overlap I talked about earlier. After that copy step, I check to see if there's any data left in the input array. If there's not, I copy the endpoint index to our result index. But if there is anything left in the array, I loop the function, and this will loop until there's no more data in that input array. Now to demonstrate what this does in more detail, let me do a manual demonstration of what this looks like for the input array A, B, B. So this is what our storage looks like before we do anything. First thing we do is copy this hold value into our lookup. So if we just copy that over, we then have 2 instances of this. This is not used because, as I said, this gets overridden. So we start with just copying this over to here, and then we remove it from the array. And then the next thing we do is, based on what character we have in that index, we then copy over a specific object. That object we're copying is this one. So we copy that entire thing over this onto itself, overwriting it. Then the next thing we do is we once again copy our value here over, and then we remove it. And then based on that, so we go from A here all the way to B here. We copy this object here all the way over the lookup once again, and then we loop once again onto this, remove that final thing from the array, and then we're looking for B again, so this one. We then copy this over, override the entire thing, and then now that we no longer have anything left in that array here, we then just copy this string into our result. So that's how it works in real time. Now, that endpoint index isn't really required if you have a fixed length for your tree. For example, colors. If you want to format colors as just the numbers of the RGB values, you would only ever need 3 indexes. No more, no less. So you wouldn't need an end index. Now, I do bring up colors in a mildly offhand way, but if you use this in any way for colors, be ready for a world of pain. The absolutely insane scale of 256 values per branch is on the border of what Minecraft can handle. I cover using this lookup system for colors in a video that I put up on TS's channel, where I also cover another use of this system, running commands. This system is not just useful for flattening strings. As I said, this can also be used to run commands. In that video, I also cover how we use this lookup system to run a specific command out of a list of 2,884,860 commands. We basically needed to generate a team prefix or suffix, and since we can't do that in-game, we pre-generated all the commands we would possibly need into one of these lookups, and then used the widths of spaces we would need as the indexes for the lookup. Now, we have come up with several other ideas that we've dropped because the size of the lookup would be literal terabytes, but really the only limitation to this system is your creativity and the amount of memory you're willing to allocate to Minecraft. Now, in this video, I did mention the text-to-speech system, and in that video on TS's channel, I talk about the camera system, so I think I'll use the rest of the time in this video to provide just some updates on those projects. First, the text-to-speech. I honestly haven't touched it since I did some updates on it last time I made a video covering it. The system itself is functional. The only real issue is voice banks. I honestly think I can make it sound decent with better audio clips. My own audio for it can probably be improved, and I might be able to get a few more banks for it if I actually sat down and worked on it. I just haven't really had a use for it to motivate me, although I might have one here soon that may motivate me to work on it. And secondly, the camera system. That is similarly functional but lacking in refinement. There really is only one large issue, a fundamental issue that I'm not sure is fixable, and one smaller issue that can be solved with a bit of brute force effort. Let's start with that fundamental and largest issue. I've said it before in other places, but the camera system breaks worlds. The image resolution system currently breaks the ability to save the world it's in when it's run, and this, in my opinion, is unignorable. I need to fix that issue first. I think I might be able to fix it by changing how it resolves the image. Instead of resolving the entire image on a sign, I should resolve it one row at a time and then resolve it in storage afterwards. Now, theoretically, this shouldn't be an issue because the chunk data limit was supposedly fixed, but it seems that it was just increased, and what happens when that limit is hit affects the entire world instead of just a single chunk. Next is a fundamental issue that I'm not sure can be fixed: the lag. Now, I could potentially try to do some compression of sorts that can reduce the amount of characters it uses to reduce the lag, or just reduce the resolution of the image, but I'm unsure how much I'm willing to reduce the resolution to increase performance. It's already a fairly low resolution image. And last is the fact that I actually have to make the color capturing. That means I need to program every pixel of every block I want to be capturable. This is, in theory, all I need to do right now to have a fully functional system if I just want the spectacle of capturing an image and displaying it in chat. But honestly, I don't just want the spectacle. I want a functional and usable camera, and with those two other issues in mind, I'm not motivated to put the color work in. Now, that is the side things I wanted to cover, since they are tangentially related to the lookup system I was covering in this video. I'll have links to Misode's stuff in the description, since he sort of came up with this, as well as links to TS's YouTube channel, and a link to Tales of Glathford, a map where we made both the most and least practical use of the lookup system. So yeah, thanks for watching, and I will catch y'all next time.